All right. When we left off, we had just introduced the first derivative test. We wrote out a methodology and just an explanation of what we mean by the first derivative test. And we have that if we have our critical number, where f prime is either 0 or undefined, and then if we look on the left or the right side of the critical number, if we determine that our original function is either, like, say it's decreasing on the left and increasing on the right, then we would expect the local minimum. And if f is increasing on the left and decreasing on the right, we would expect a local maximum. Okay. And then I think we also made a statement where if it's both increasing on the left and the right, or if it's both decreasing on the left and the right, then it was neither a relative maximum or a minimum. So this is just going to be a continuation of 3-2 Extrema and the first derivative test. We didn't go over any exclusive examples, so I'll just do a few examples now to connect those ideas. So again, this is a continuation of 3-2 Extrema and the first derivative test. This will be example 1. Find all relative extrema of the function. So we have f of x equal to 2x cubed minus 3x squared minus 36x plus 14. So if we want to find the relative extrema of this function, again we said that at those extrema, your f prime is either going to be 0 or undefined, so we need to look at f prime of x. That's going to be 6x squared minus 6x minus 36. So again, this is a polynomial, so we're not going to have any x that makes us undefined, but we are going to have something that make it 0. So if we set this to 0, and solve for x, now notice you can factor out a 6 from each of these terms. So then you have x squared minus x minus 6 equal to 0. So then this can be factored. Let's say we have our x and an x. This minus tells us that the two signs are different. Okay. So two numbers that multiply to give us a 3, two numbers that multiply to give us a negative 6 and add to give negative 1. So that would be 3 and 2. So 3 times 2 is negative 6. Notice that negative 3 plus 2 is negative 1. So this is going to be our factor. So this tells us that when x is, let's see, 3 or negative 2. When x is negative 2 or 3, it'll make our function 0, or our f prime 0. So now we just make a table. So we're going to make a table where we have interval, and then we have our test value, then we have the sign of f prime, and then we have our conclusion. Okay. So now if I have my critical numbers are going to be -2 and 3, so if this was -2 and this was 3, this tells me I need to test from -infinity to -2. I also need to test from -2 to 3, and I need to test from 3 to +infinity. So -2 to 3, I can choose, oh, actually let's back up. So I'm going to start off with -infinity to -2. I can choose a test value of x equals a -3. So if we look at the sign of f prime of -3, that's going to be 6 times -3 plus 2 times a -3 minus 3. That's going to be equal to 6 times a -1 times a -6. It's going to be a +36. So this tells us that f prime of -3 is positive. So that tells us that on this interval our function is increasing. If we look at -2 to 3, we can choose a test value of x equal to 0. If we look at f prime of 0, f prime of 0 is going to be 6 times 0 plus 2 times, it's going to be 0 minus 3